Welcome to Mathematic 59, my YouTube channel. First video in a while. This is a logarithm equation. We talked a little bit about how when you have a logarithm situation with a base, argument, the getting the logarithm treatment, and it corresponds to its answer, which is also known as power. It can be rewritten as the exponential, where its base raised to the power is the argument. Very important. It's the only way you can solve logarithm equations. Also, it helps immensely on a lot of exponential equations too, because there's a lot of exponential situations that you want to convert to a log form in order to cancel things out. So in this particular case, I like to point out to folks that this is the base. The power is 1, and the logarithmic argument is that incomplete quadratic. And that incomplete quadratic gives a lot of people trouble. Keep that in mind. The base is, sorry, I seem to be getting messy. So what that means is if I follow the model here, I'm going to get 2 to the 1 is 6x squared minus 7x. We're now 2 to the 1. Yeah. You have to follow that carefully. And if you're struggling to understand the whole big idea, now people do have trouble with the quadratic as well. But then you have a situation where you have an quadratic on one side and 2 on the other. Now, you cannot divide by x. You can't factor out x. This isn't a zero product property. You should always try to get these quadratic equations into a zero product property situation first, or at least get it into what they call standard form. You might recall from previous classes, this is standard form. And you also might recall from previous classes, when something's not factorable, you could use the quadratic formula. And that's going to be our only choice on this problem. Yeah, you could try factoring, but I found out that you can't exactly factor this, because if you multiply 6 times -2, that's -12, and there's no factors that add up to -7. You could try factoring too, but you'll find out that there's no way you can factor it. So going to the next step involving quadratic formula, I'm going to go ahead and go to another screen. But make sure it's noted that A has to be 6, B has to be -7, and C has to be -2. And remember, C has to be on the same side as x squared and x. So here's how it's going to look moving forward. Then A is -7 and C is -2. Sorry, I got to go back and look. X would equal, based on the quadratic formula, the negative of -7 plus or minus, and this is a very hard one to fall for a lot of folks. You have to write square of -7, and you have to get a positive 49. Then you're going to write negative times -2. This is going to be over 2 times x. That's a quadratic formula. And then I'm just going to go line by line. You're going to go ahead and simplify the 7. You're going to do the square. Now, you're going to get a negative times a negative, which is, you need to, the minus sign serves as a negative of that expression. And that's going to lead to 48. And this is going to be 12. And then x is going to be 7 plus or minus the square root of 97 over 12. Now, what that means is you can also break this down into two solutions where x equals 7 minus the square root of 97 over 12, 7 plus the square root of 97 over 12. Now, even though this is a logarithm equation, both solutions will pan out because both solutions stay within the domain of the original logarithm expression. There are going to be some logarithm equations where if you're doing some condensing, you may have to go and check solutions. So that's how to work this problem. And make sure you tune into as many other videos as you can. Have a good day.